Okay, let's go ahead and get started here. You're going to need this sheet of paper here and some graph paper, and then right there, that's what you're going to do to take notes. When you get to the graphing problem, you want to do it on the graph paper. You're not going to want to do it on the notebook paper. Okay, we might want to write some stuff down on this paper. The problems don't, except for the graphing problem, a lot of the problems go pretty quickly. Okay, so notes. Okay, number one, I'm actually going to kind of work with the table here. Write an equation for this table. Temperature in Celsius degrees, you go from 0 to 5 to 10 to 15, okay? The velocity in meters per second, so when it's 0 degrees, it's 331. Then when it raises to 5 degrees, it's going to be 334, 337. You can see what goes on the table. Here's how you write an equation. This is your dependent variable here on the far right-hand corner, okay? You put V equals, nothing else over there but V. Then where does your V start at? 331. And then what's it doing, going up or down? Well, it's going up, okay? If it's going down, you minus, going up, you plus. Now, what are you going to plus? Well, here's what you're going to do. I know this seems kind of like, you have to start on this column, and you're going to start at the end, go 340 minus 337. That's 3. Go 337 minus 334, 3. 334 minus 331 is 3. So remember, we're adding, so every time it goes by 3, okay? So you're going to put 3, then you're going to underline 3, and you have to look over here. So 15 minus 10 is 5, 10 minus 5 is 5, 5 minus 0 is 5. So that's also going up by 5 every time. Now the reason that's important, you have your 3, but you need to underline 3. And it's a ratio of 3 to 5, okay? So again, that goes up 3. So again, 3, 3, 3, 5, 5, 5. So 3 over 5. It's got to be 3 over 5 because you started with the V, so 3 over 5. Now, next to the 3/5, you need to put a C variable right there. And there's your equation. Now here's why that works, and that's your answer, okay? Okay, remember to get the C in there, the variable C. If I go to my calculator and punch in 331 times R plus 3/5, 3ABC 5, and then I times by 0, okay, I'll put 0 in for C, 331. Now if I times by 5, I get 334, okay? If I times by 10, I get 337. If I times by 15, I get 340, okay? So it matches up perfectly. It's going to V equals 331 plus, and then what's it going up by here? 3. It's going up by here 5, 3 over 5, then you put the C with it. Okay. All right. Number 2, tell whether the function is linear or nonlinear. Here's what you're going to do, okay? Start with your 7. 7 minus 3, that's 4. Start at the end. So put a 4 between them. Now take 3 minus negative 1. That's 4. Now take negative 1 minus negative 5. That's also 4. So every time it's going by 4. Now, so since it's the same every time, it's linear. Okay, number 3. Tell whether it's linear. Well, 10 minus 5 is 5. 5 minus 2 is 3. 2 minus 1 is 1. That's all different, so it's nonlinear. So pretty easy there. When it goes by the same amount, when your dependent variable is increasing by the same amount every time, then it's linear. If it's different amounts, then it's nonlinear. Okay, number 4, we need to go to our graph paper. We need to graph the function y equals negative 4x plus 3. Here's how this is going to work. You're going to make an xy table, and for x you're going to put negative 2 through 2. Here's how you figure out your y. Put a wall on the side of the y. Okay, y is by itself. Now dot your x, don't circle it, okay? And what you're going to do is replace x with negative 2 first, okay? Negative 2 in for x. So we have negative 4 times negative 2 plus 3. Then negative 4 times negative 1 plus 3. I'm putting negative 1 in for x. Now I'm putting 0 in for x. Negative 4 times 0 plus 3. Negative 4 times 1 plus 3. And negative 4 times 2 plus 3. Okay, find out what those equal, and that's going to be our y. Okay, so negative 4 times negative 2, that's 8. And then, oh, I forgot to add the 3, my bad. Don't put 8 now. We take negative 4 times negative 2 is 8, and then we have to add our 3. Okay, 11. Negative 4 times negative 1 is 4. Positive 4, then add 3, you get 7. Negative 4 times 0, 0 plus 3, though, is 3. So it goes from 11 to 7 to 3. Then it's going to go into the negatives. Add 3, negative 1. Negative 5. Okay, now how do you graph it? Well, this is your x. This is your y. Now you might want to label this. In this quadrant here is the positive quadrant, okay? This here is the negative positive over here because you're going negative but up still. Down in this quadrant, that's when they're both negatives, and down here is when they are positive with negative, okay? So plus, minus, minus, plus, plus. Now number them, so you have 0, 1, 2, if you need to. If you can do this, make the points without numbering, that's fine. I'm going to number them just so people can see. Negatives are going this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Okay. Okay, so negative 2 goes with 11. Okay. So x is negative 2. And then 11 is up here. 9, and then you got to go past it. Okay. Negative 1, 7. Okay. So you go left 1. Up 7. Negative 1, 7. 0, 3. So 0's here, I just go up to 3. 1, negative 1. 2, negative 5. So 2, negative 5. Okay, now I'm not going to distribute rulers today, so you have to make the line as straight as possible. Now you're making a line because you can also have points in between, decimals, so that's how you make it continuous, is with the line. Okay, next one. Number 4, so you go to number 5. Okay, identify the domain and range of each relation. Tell where the relation is a function. So domain, range, this is easy. The domains are your x coordinates. So you get xy, 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 xy. All the x's are your domains. So negative 2, 8, 3, 5. Your range are the y's, 5, 6, 12, 6. Now I want you to just look at the domain. Do you have any repeated numbers? No, they're all different, so it's a function. Okay. Number 6. Domain and range of the relation, so you got 9, 3, 4, 9. 6, 8, 9.5, 2. Domain, range. Okay, function. Well, I have repeated 9s in the domain. Okay, it's all about the domain. You don't care really what the range says. Okay, it's just domain. There's repeat 9s, so that's not a function. Okay, number 7's pretty easy one. A bottle holds 48 teaspoons of vanilla. The amount A of vanilla remaining in the bottle decreases by 2 teaspoons per batch of cookies. Write a function rule for the situation. First variable is A. Put A equals, that's the amount of vanilla. You start with 48. Then you decrease by 2 tablespoons per batch. So decrease means minus 2, but you need to put B because it says per batch, times the batches. So A equals 48 minus 2B, which means 2 times B. Okay, number 8, you're going to want to have one whole page for number 8. Okay, you're buying streamers that cost $247 at each for a party. You have $30 to spend. What's a reasonable domain and range of this situation? And then is the function continuous or discrete? So you're going to put D and R. Then you're going to need to make an XY table. So the 2 units in bold are streamers and dollars. Dollars is Y, streamers is X. Now start off, do your 0, 1, 2. So if you don't buy any streamers, you don't pay any dollars. If you buy one streamer, you pay $247. Put times 2.47. Don't do anything up on the 0. Don't worry about that. By the way, you can put times 2.47, but 0 times anything, 0. Now take your 2 times 2.47. Okay, 494. Now what's the limit? There's a limit to this because you only have $30, so you need to stop at 30. But you got to find out what goes with 30. So put question mark, but you know it's times 2.47. So to find what would go there, okay, you need to divide 30 by 2.47. Write that there. Don't divide 2.47 by 30 or you get something different. Okay, just put 12 because you can't buy a decimal for streamers, okay? So just put 12. Now, but is 12 times 2.47 30? No, it's 2964. So you now need to replace the 30 with 2964. Now you have your domain and range. So the domain goes from 0 to 12. The range goes from 0 to 2964. Now, continuous or discrete. Between the 1 and after the 2, I want you to put 2.5. Can you go to a store and buy 2.5 streamers? Does that make any sense? No, it doesn't. So it's discrete, meaning decimals would not be included in this situation for the domain, okay? If you can have a decimal, it's continuous. Okay, let's go to the next back page. I'm going to do another one. Okay, write an equation for the table. So you start with the gallons. What do the gallons start at? 11.2. From there you're going down, so this one's going to be a minus. Now to find out what you're going to minus, here's what you do. Start at the bottom. Take, and by the way, we're going to minus, right? Okay, yep. 8.2 minus 9. Okay. 8.2 minus 9.2, negative 1. It's negative because you're minusing. 9.2 minus 10.2. 10.2 minus 11.2. I got 1 every time. I got negative 1, but I already put the negative down when I put minus, so it's always 1. Okay, 1 over, now jump over here, 51 minus 34, 17. 34 minus 17, 17. 17 minus 0 is 17. So that one's 17 every time. So the 1 has to be placed over 17. Then you, since the table would go on forever, you put the m variable on it. Okay. 11.2 minus 117 down. Now, one thing on this ratio you should do, on the first one, take a calculator and divide 3 by 5. If you get a decimal, just leave it, okay? So I left it as 3 over 5. 1 divided by 17, it's not 17, it's a small decimal. I got a decimal, so I'm going to leave it, okay? So that's my answer. G equals 11.2 minus 1/17 m. Okay, is it linear or not? 14 minus 11 is 3. 11 minus 8 is 3. Yep, that one's linear. So number 2, linear. Number 3, 72 minus 12 is 60. 12 minus 6 is 6. That's non-linear because you got different things every time. Okay, number 4, I want to go back to your graph paper. We'll do it down here. Y equals 1.5x minus 2. Okay. So make an XY table. You're going to put -2, -1, 0, 1, 2 that way. Now your y is by itself. You're solving for y. Y is by itself, so I just need to put a dot and replace the x with these numbers in the column. 1.5 times -2 minus 2. 1.5 times -1 minus 2. If you want to make that a plus -2, that's fine, or you can just go with minus. 1.5 times 0 minus 2. 1.5 times 1 minus 2. 1.5 times 2 minus 2. Okay, so 1.5 times -2, and then you have to add the second -2, or minus 2. Let's just do minus 2. -5. 1.5 times -1 minus 2. It's -3.5. Anything times 0 is 0, which you're just going to get, and then when you have -2, you just go to -2. 1.5 times 1 plus negative 0.5. 1.5 times 2 plus -2 is 1. Okay. All right, now graph. Remember, positive, positive, negative, positive, negative, negative, positive, negative. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -1, -2, -3, -4, -5, -6, -7, -8. And we're ready to graph. So -2 is with -5. So I go -2, -5. -1 is with -3.5. So -1 is here. -3.5 is halfway between the -3 and the -4. 0, -2. So 0's here, -2's here. 1, -0.5. So 1. Now where would -0.5 be? Well, halfway between the 0 and the -1. And then 2, 1. So 2, 1. That's in the first quadrant. And then there, it's a linear graph. All right, number 5. Identify the domain and range of each relation. Tell whether the relation's a function. So it's easy. Negative, these are my x's. -2, 0, 4, 5. So domain. And the range, we have 0.5, 2.5, 6.5, 2.5. Now, at this point, we don't care about the range. When we're trying to tell whether it's a function, we just care about the domain. There are no repeats, so it's a function. We have number 6, domain and range. 6, 4, 6, 5 is the domain. The range, 5, 3, 4, 8. Okay, and your repeats in the domain, yep, the 6. So we have not a function. Okay, number 7. The volume remaining in a 243 cubic foot pile of gravel decreases by 0.2 cubic feet with each shovel of gravel spread in a walkway. Write a function to represent the situation. So V equals, it starts at 2, it's like this, only you don't have to worry about the table. You start at 243 and you decrease by 0.2 cubic feet with each shovel. So minus 0.2 S, because that goes down every time you shovel. So it goes by multiple times. It goes on forever, so we put the S variable. Okay, then number 8. Markers cost $4.99 at a store. I want to buy as many as I can. I have $40 to spend. What's a reasonable domain and range of this situation? Is a function continuous or discrete? Okay, first off, domain, range. If it's a story problem, you have to make a table. Okay, X, Y. Okay, markers and dollars, so dollars, markers, and you can do the 0, 1, 2. So 0 markers would be $0. If I buy 1 marker, it's $4.99. So 1 times $4.99 is $4.99. If we buy a second marker, I times 2 by $4.99. $9.98. Okay. And go up here, you could take 0 times $4.99, but that's 0. Anytime one of the factors is 0, it's 0 no matter what you times by. Now there's a limit. The limit's $40. Okay. We don't know this though. But we know whatever it is, you have to times it by $4.99. So to find what it is, we do the opposite of times, which is to divide 40 by $4.99. Okay, 8. Because you can't buy decimals for markers, it's 8. But is that actually 40? If I take 8 times 4.99, it's not, it's $39.92. Okay? So again, the limit to your range is not actually 40, so you got to go back and remultiply it. So 0 to 8 is the domain, the range 0 to $39.92. Okay, continuous or discrete. Well, if I buy, can I buy 2.5 markers? No, that's discrete. All right, now we'll go over one more. And I'll do this one. Okay, number 1, write an equation for the table. So S equals, starts at 48, then it's adding, okay, so you know it's a plus. Now, what are you adding? Well, you can start at the end and subtract, actually. You can always subtract. 72 minus 64, 8. 64 minus 56, 8. 8. So 8 over 6 minus 4 is 2, 2, 2. So 8 over 2, now put the variable m. Now in the last two packets I divided. You always want to divide your ratio. If it's a decimal, leave it. That's your answer. But if it's not a decimal, you need to replace the 8 over 2 with 4. So S equals 48 plus 4m. Okay. Now, I didn't do that on the last two because I divided that as a decimal. So you want to make sure you do that. Don't write it if it's a decimal. Okay, number 2, linear or nonlinear? Well, let's see. 4 minus -6, that's 10. -6 minus 5, -11. So I already know it's not linear because it's different. Okay, -2 minus 1. -3. Don't put -3, just put 3. Okay. When doing these, you can put -3, that's fine. Okay. 1 minus 4, -3. 4 minus 7, -3. Okay, that one's linear. Okay, graph the function y equals 2x plus 1. Okay, forget that thing in parentheses that I wrote. Don't worry about it. Okay, do not worry about it. So go get your graph paper. -2 through 2. By the way, you could do -5 through 5. You could do -15 through 15. I just do it so I can get a reasonable amount of points without torturing myself. So we're solving for y. Y is by itself, so we just insert in for x. So 2 times -2 plus 1. 2 times -1 plus 1. 2 times 0 plus 1. 2 times 1 plus 1. 2 times 2 plus 1. So that's -4 plus 1 is -3. 2 times -1 is -2 plus 1 is -1. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. Okay, so here we have positive, positive, negative, positive, negative, negative, positive, negative. -1, -2, -3, -4, -5. 1, 2, 3. And you don't have to number if you don't think, if you can get the point in the right place without numbering this all, be my guess. Okay, so -2, -3. -2, this is x, this is y. So x is -2, y is -3. -1, -1, so -1, -1. 0, 1, so x is 0, we stay in the middle, but 1's up here. 1, 3, so 1, 3. 2, 5, so 2, 5, and it is a linear equation. Now it's continuous, it's not a story problem, so you could put, the reason why you have to connect the dots is because I could put 2.5 in for x and find what it is, okay? You know, I mean 2 times 2.5 plus 1 is 6. Don't write this, but, so 2.5, 6, 2.5, yeah, right there. See, that's why you have to make the line and connect them. Okay, number 5. 5 and 6 are easy. Okay, the x's are your domain because you have a coordinate xy, 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 xy. Domain, range. Domain, we have 0, 1, 2, and 1. Range, we have 0, 4, 7, 6. We have repeats right there, so that is a non-function, not a function. Again, it's all about the domain. Range doesn't really mean anything as far as determining whether it's a function or not. Domain range, -2, -1, 0, 1, 2. Okay? And the range 4, 1, 0, 1, 4. Remember, you don't care about any repeats in the range. It's all about the domain. There's no repeats there, so we have a function. Okay, number 7. I have 512 megabytes of memory on my computer. That amount decreases by 3 megabytes per photo I upload. Write a function rule for the situation. So M equals, and we start with 512, and we decrease by 3, so -3. But you don't decrease by 3 just once, so that's why you need to put a variable there. It's per photo, so you put P. Okay, number 8. I make $25 per hour at my job. My boss has a limit of 35 hours for each employee. What is the domain and range of the situation? Is the graph continuous or discrete? So domain, range, then is it continuous or discrete? Don't forget to do that. Okay, so I have dollars and hours. So X is hours, Y is dollars. 0, 1, 2. Well, 0 hours is $0. Now, if I work 1 hour, I'm going to make $25 because 1 times 25 is 25. If I work 2 hours, 2 times 25 is 50. Okay, you just times by the rate of change. Okay, I have a limit here. 35, but it's 35 hours, okay? That actually makes this a lot easier, okay, when they give me the limit for the domain. Because I'm just going to times that by 25, and I'm going to have my answer. 875. I don't have to remultiply because I didn't get any decimals involved. So 0 to 35 is the domain. The range runs from 0 to 875. Okay, now I'll put 2.5. Can you work 2.5 hours? That's 2.5 hours. Yeah, you can. So since I can have decimals, it's continuous.